Good morning, good afternoon, and good evening. Welcome to yet another session at Percona Live. The topic Presto DB Administration Fundamentals: Why, What, and How. I am Ravi Shankar. I am Chief Consultant at Passion Bytes. We specialize in distributed computing, big data, and Presto DB related implementations. Why Presto DB? So decades before, if you look at enterprises, you might be seeing one single monolithic database which is sufficient for almost all OLTP needs, not much OLAP, maybe data warehouse also combined into that particular database vendor, and there can be so many reporting and analytics out of that single monolithic data source. But I'm confident to say that if you are starting a new strategic enterprise application, you might no longer be assuming that your persistence should be only relational. And there is an excellent paper Martin Fowler has written where he illustrates this idea called polyglot persistence. It is possible that some services might be using a transactional OLTP RDBMS system. There can be key value stores for lookup data. Document-based databases might be there. Graph-based databases might be there. And a lot of archival related databases are possible. So we have got disparate data sources spanning across the enterprise. And one of the basic needs is analytics, machine learning, and reporting, where you might not be relying on only one kind of data source, but you need the data from all these disparate data sources. That creates a little bit of problem because you might now be thinking of ETLs, extract, transform, loads, tools, and then copying the data from one over the other, or creating a temporary storage, staging areas, etc., etc. And this is where exactly Presto DB comes handy. So, the best way to think Presto DB is as what I have shown here. Assume that it is a dynamic HDMI hub. Why it is dynamic? Today you are seeing only input 1 to input 5, and there is a possibility for an output as well. And the HDMI ports that you are seeing across the inputs can take, let's say, each data source. For example, input 1 may be Oracle, input 2 may be MySQL, input 3 may be MongoDB, input 4 might be a Hive based data source, and your output is going to give you the result from either individual data source or a combination of one or more of them. And that's what Presto DB is all about. It's open sourced by Facebook in 2013, and it is designed and written from the ground up for interactive analytics at the start, but currently, as we see a little bit later, it supports batch-based execution and ETL jobs as well through an advanced recent innovation running on Spark. The community owned and driven Presto project is supported by Presto Foundation, hosted under Linux Foundation. And as you see on the right hand side, multiple data sources, polyglot data sources can be combined, and you can just execute ANSI standard SQL to get the relevant data. So, what is Presto DB? It's a high-performance, massively parallel processing SQL engine. It supports interactive and batch execution. It is completely compliant with ANSI SQL queries. It's proven for its scalability and concurrency. And it supports connector-based approach, which we will explain soon. And as mentioned, it's managed by Presto Foundation hosted under Linux Foundation. It can be deployed on-prem, cloud, or hybrid. If you look at the number of users of Presto, you can see that almost all the biggies who are dealing with petabytes of data are the customers of Presto, which clearly proves its scale. And please look at the link to see the latest snapshot of the users. At a high level, if you look at the architecture, PrestoDB is a combination of a coordinator and one or more workers. Coordinator, also called as the queuing node or the master node, is responsible for managing the cluster. For example, it receives the queries from the client, analyzes the queries, uses the metadata to find out what is the best way to get the details about the query, and then plans it and then schedules it onto one or more workers. Workers in turn will be connecting to the individual data sources that you can see on the right hand side, gets the data, and if there is a join, then joins the data within the Presto workers, and then finally gives to the client. And as you can see on the right hand side, the data sources are implemented within PrestoDB as catalogs. Each catalog can contain one or more schemas, and each schema, like a relational database, can contain one or more tables. This is a small summary of PrestoDB ecosystem. So, how to use PrestoDB? Let me describe two ways. One, the easiest way is to get a Docker image, thanks to Ahana, one of the Presto Foundation members. And if you look at that site, and you can pull the PrestoDB server, which is the first link, and the second one is the PrestoDB CLI, which stands for command line interface, and within minutes you can get it running, and you can run some queries on the sample catalogs provided like TPCH, TPSDS, etc. If you want instead an AWS AMI or Google Cloud, the same site gives you those images as well. But since we are dealing with a little bit more details on how to configure Presto and learn about the administration fundamentals, let us look at a manual installation. So, if you look at the PrestoDB website, you can see docs, which is a link on the top, and if you look in docs and click on the deploying Presto, you will see that there is a link for the server file, and on the left hand side command line interface there is a link for the command line executable jar file, and optionally you may download a JDBC jar file as well if you want to connect it from standard Java based applications or any reporting applications. So 3 files is what we need, and we are going to use this into our system. So let's open a command prompt, and I'm going to go to my directory where I have already downloaded the server file and the command line executable file as well as the optional JDBC file. You untar this server files to get this directory Presto Server 251, which is the latest version as of now. And go to the directory, and if you look at a list of the files or directories, you will see about 3 of them except etc. etc is the one that you must create, and if you look inside etc, it will contain some files. And to know the details about the files, just browse down the same link and look at the deploying Presto, come down, and you will see one file is called config.properties, another one is called node.properties, and the third is called jvm-config, where you will be keeping some of the options for how much heap size you are going to use, as well as the config file will be telling you where or which port you are running your PrestoDB cluster. As you can see, there is an important line which is the second one in the config.properties. If you are telling false and you are saying that your coordinator is standalone, that means you are really creating a cluster with coordinator as a separate dedicated node and multiple worker nodes. To start with, you may configure that value as true so that the coordinator and the worker are running on the same machine, which is what I have done in my example. So if you look at our config.properties, you can see that this value equal to true and the port in which we are going to run this application is 8080, and all the worker nodes is going to connect to the server through a discovery URI. There are some other options which we will be discussing later. These are all the tuning parameters that you can use either globally or at a connector level. Well, if you are looking at the other property which will contain the maximum heap size that the server can use, and these are some of the options which will help you to debug the Presto cluster. And node.properties will contain a unique node ID for each of your Presto cluster. Once you have that, you can go to the catalog directory where you are going to configure the connectors. But before doing that, let me just give you the context. If you look on my right hand side, you can see that there are 3 windows open and each window is a kind of data source. For example, the first one is the Oracle data source, and I'm running Oracle on a Docker container, and as you can see that I'm running a query on the Oracle with Scott as the username and Tiger as the password, and I'm getting this particular data. Secondly, if you look at this window, you can see that MySQL is running, so Oracle MySQL. And third, very interesting, I have downloaded an open source object store called Minio just to illustrate the connectivity of PrestoDB with S3 protocol. Minio supports the official S3 protocol, and if you can connect to S3 protocol on Minio, that means that you can connect to any of the AWS based S3 as well. So just to illustrate that idea, we are running Minio as well, and as you can see, it is protected by an access key and the secret key, which are the default values when you are installing first time. Alright, now let's come to the catalog that we are talking about, and it is time to configure the catalogs. And if you look at the list of the files that I have kept inside a catalog, you can see there are 3 which is corresponding to the 3 data sources which I have just explained. One is the local.properties where you are connecting to Minio using the access key and the secret. There is no S3 connector as such for PrestoDB, and the way PrestoDB connects to S3 is through Hive Hadoop 2 connector. And if suppose you are looking at the MySQL connector, you will see the corresponding details for connectivity to MySQL. Similarly, Oracle.properties will tell you the Oracle properties that is needed for connecting it. And you want to know the list of all connectors, you can just go to this particular site which we have seen earlier and click on connectors. Initially, when Facebook open sourced it, there were 3 to 4 connectors, and now you can see that the ecosystem is growing. And that's why I mentioned earlier that think of a dynamic hub, HDMI hub, where the number of inputs are growing as we have more and more connectors. Alright, coming back to our system, we are now going back to the parent directory, and let's start Presto by typing bin/launcher, either start or run. Start will use a background process, run will show you the console. This is a Python script, so the basic requirement for running PrestoDB on your computer is Java 8++ and Python. And when you start the Presto cluster, you will see that the console logs are now creating all the necessary connections, etc. And finally, you get a message, the server started. And once the server is started, we can go to another window and we can start issuing the queries. So let me go to the same screen where same directory where we have the server, and we downloaded the client file, which is the CLI executable files, and the Presto prompt shows that it is now ready to accept the queries. This is the place where you are going to type your ANSI SQL queries. So let's start by the basic command show catalogs, and you are going to see the catalogs that are being configured plus one extra one called system, which is internally used by PrestoDB. You can run some queries on the system catalog to get the runtime information. For example, if suppose you want to know how many runtime nodes are there, then you can issue a command called runtime not nodes, so that it will give you the list of nodes that are available running on your system. And please look at every query status. You can see number of splits, and that shows how PrestoDB is executing the queries, completely parallelized, distributed, right? But that is not what we want to do. We want to query the MySQL database from this particular window, and let us write the query for querying the MySQL database. And now you see the power of Presto. Without changing the interface, let us now query Oracle. Polyglot data sources you are connecting through one single window through simple SQL. You don't need to worry about the internal intricacies of the underlying data stores, like whether it is a NoSQL MongoDB data store or Pino or Kafka. It allows you to query everything using simple SQL. What not? You can just run a query to join the data between the multiple data sources. As you can see here, I'm joining the MySQL as well as Oracle on a join condition, and you get that result now. And if you want to see what is happening under the hood, you can just go to the admin UI supported by Presto and just run localhost colon 8080, which is the port where our server was running. And you can see that there is one active worker, and if you click on the finish tab, you will see all the queries that I have just executed. To get the details of this query, you can just click on that unique ID, which is representing each of the queries, and then you can see how the query got executed. And for this example, the query got translated into 4 stages. So every query is internally planned by dividing it into multiple stages, and then everything is getting executed. And if you click on the live plan, it will show you how the query execution plan happened. For example, it is bringing some data from the database here, and on the left hand side you can see there is another data coming from the other databases, which is MySQL and Oracle, and then the combination or the join is happening within the Presto cluster, and finally the result is being delivered, and the final result is 107 rows. So you get all these details by looking at the Presto admin UI. Coming back to our presentation, if you look at the use cases, one, obviously you can see that data virtualization. The user is completely transparent about from where the query is coming in. Why? Because everything is happening under the hood in the catalogs. You are configuring all the individual data sources, and the user is just executing the query against each catalog and the schema and the table. Another use case is for creating modern data lakes. And let me just explain you, when you go back to the same window where you executed the queries, remember that we have started an S3. Assume that your MySQL and Oracle are OLTP systems, and your enterprise or organization does not want you to query the OLTP systems. Why? Because it may be serving customers and serving the microservices for online use. You might require to load that data, the joined data, into a data store or a data lake, so that your data scientists and data analysts can query the data store instead of hitting the MySQL and Oracle databases. How can we do that? Just create a table, and in this case I am going to create local.sample.percona as the table. Create table as is the command supported by Presto. And local.sample.persona, remember local.properties is pointing to min.io through the Hive connector. And once you do that, you will see that now it is creating that final result which we have seen earlier into this particular table. And now you can just write select star from local.sample.percona in order to get the result of your query, that is combining the data from multiple data sources. this particular data lake can be used as the input for your data analysis or your machine learning needs if you don't want really real-time data. All right, that is the second use case. And now if you look at the final use case, of course, you can see that you can apply any machine learning algorithm on this combined data because a JDBC jar file is being provided. You can connect it from any of the systems and run algorithms. And these three use cases are just simple representative samples. Just extend it to any type of use cases that you would like to do with multiple data sources. All right, now how to tune Presto. If suppose you are looking at the properties of Presto in the same website and click on administration on the left hand side and then tuning Presto, you can see some of the JVM settings, but that's not much important. But the properties reference is where you will be configuring all the properties. There are many, and the default setup of Presto which is coming out of the box is more than sufficient for handling most of the workloads. But if suppose you want to have your own mechanism and tune the queries, then there are some properties. An example, one of the very important property is joint distribution type. The default type of distribution supported by PrestoDB is partitioned, but you can use broadcast. For example, if you are joining a big table with a small table, you may use a broadcast join where right side of the join should be the small table so that the small table is getting propagated into all the worker nodes, a copy of the table. Automatic will allow Presto to use a cost-based selection. You can use resource groups and the concepts behind it in order to create priority for your queries. So please refer to the documentation for more details. Now, one very important aspect, recent innovations in PrestoDB is Presto ARIA, which is allowing you push down predicate logic into the data source. Currently, Hive connector is what is being supported for Project ARIA on ORC format, optimized raw columnar format. And to explain you what it is, let us look at the next slide. If you are not configuring Project ARIA, you are going to do a complete table scan on a select star with a filter condition, and then the entire data is coming to the PrestoDB engine. The area on the top of this line is the PrestoDB server and the coordinator and the workers, and then the resulting data is getting created within the PrestoDB engine. And this is not an optimized or an efficient way. What we can do is we can fetch only the relevant data by pushing the filter logic as well into the data store so that the Presto engine is retrieving only the data that is required, and that's what Project ARIA is all about. Please look at this link and watch the video for a complete demonstration of Project ARIA. The next important aspect is running PrestoDB on Spark. So let me just open another window and let us start the Spark master. So here I am starting the Spark master server, and then let us start the slave which is connecting to the master, and the name of my machine is Passion Bytes. So I am going to write Passion Bytes and the port where the master is running. And now the master and the slave are running on this particular port. Let me just look at that. There is a small problem with the command master. Oh, sorry. It is spark : the machine name. And you can see that now the master and the slave are running. And if you come back to the UI and look at the port where you are running your Spark, and you can see that Spark server is up. There is one worker and there are no jobs. You can open a new command prompt and let us go to the same directory, and let me show you a script where you do a Spark submit to that master where we have started Spark and running the Presto engine on Spark by providing the query that you want inside a file called query.sql. So what you are doing here is that you are leveraging the power of Spark's fine-grained resource management and scalable materialized exchange mechanism, and extending Presto not only into interactive use cases but batch-based ETL workloads as well. And let's do this and let's see what is happening. It is now running, the Presto DB engine is running on Spark by leveraging all the capabilities of Spark except the computation engine. Computation engine is still Presto, and you can now see that the result is getting executed, and finally you are getting a count of the number of rows in that particular table, because my query was very simple query just to illustrate you this particular concept, and you are getting that output back. So let's look at the output here. You can see there is 1 million, more than 1 million rows in that particular table, and if you refresh your Spark UI, you will see that the job Presto is completed, and it is successfully done within 27 seconds, and you can see how it got executed depending upon the parameters that you have supplied. So coming back to our deck, those are two advanced features in Presto DB. And you can connect to Presto from JDBC, as I mentioned. You can connect from Python. You can use R Presto from R environment. And let me just show you how you can do that. If you look at this code, and you see that you can use a package in Python called PyHive in order to connect to the Presto DB server and get the unified data, as you can see here. And if you are using R, you can use R Presto, which is another package, and use the same idea where you will be connecting to your Presto cluster and run the joint query. Interestingly, there is a client that is available from Node-RED, and that allows you to install Presto on a Raspberry Pi and then execute the Presto engine on a Raspberry Pi, provided some changes you need to do on the Hive connector files to deploy it on an ARM device. The other features, there are custom functions that are provided inside Presto DB, which you can seamlessly extend. And one of the very widely used function, one of my favorite, is the machine learning functions that are available. And if you look at this particular query, I am executing a classification algorithm to identify what is the type of iris data that is coming from this particular value, and I am applying it against the model. The model is created inside this particular select query, and if you execute this, it will predict that this particular value is corresponding to Iris virginica. More, Presto supports one of the implementations of hyperlog log data structure. Hyperlog log is a very advanced data structure where you can run probabilistic algorithms, and this example, when I am running a cardinality on this particular data, where I am converting a kind of IPs into hyperlog log data structure, it will reduce the amount of space that is needed to store the data as well as the execution time, and you get immediate result if you are looking for approximate results, right? So great features, and please look at the resources for getting more details. The official website, you can just look at all the documentations that is being provided there, and some of the links are here. You can just read it and extend your knowledge on using Presto. So we are smarter than me. What makes Presto powerful, mightier is you. So please take some time to join any of these channels. Join Presto Foundation, and help us grow better and mightier. Thank you very much for listening. You enjoy rest of your day.